but that's not why I'm here. My day job is all about selling open source solutions and talking about software solutions to companies. When I don't work, I use open source for everything I do. I even use open hardware. And what you can see in this picture is actually a CPU that I built from scratch with all standard TTL components, nothing else. So basically that's the kind of computer we had in the 70s. Before we really had microprocessors that, like the 8080 and all that stuff.
Wait, you're making a primitive computer out of the TTL chips?
That's what this is. It's a working computer. Right? So there's lots of it's all technology. I've always, before I became into computers, I wanted to be an electrician, or actually something that dealt with electricity and setting up sound and all that stuff. It turned out colorblind people can't set up a component that has all these different color codes. And to this day, I can't read a resistor because there's too many weird colors that I can't identify. So I had to find another career, and that became computer science instead. But so lately in my career, I found that I can go back to that now, and there are better equipment today to easily see sizes. I mean, resistors no longer are this big, like they are minute, so it doesn't really matter. You need a microscope anyway to just see what they do. So I've been able to take that up, and with all the IoT microcontrollers on top of that, that means I can now program to the hardware directly, and that has sort of opened up the universe of what I started out learning in the late 70s, early 80s. So yes, I'm an oldie. My first Linux was 099B. So my first time I got Linux, I had floppy drives that was this tall, like 30 or 40 of them, for the first Slack out there to install. And I still remember how mad I was when I got down to like number 22, when that was a read error. I had to start all over again. That's a slow process. I speak at a lot of logs. I spend time managing two logs, getting people in to speak like Mark does, or run them, logistics, go to conferences, speak there. And it's mainly about software of some kind, or how other people can use some software to build other software. Most people don't use Red Hat directly, but when I describe something what Red Hat does, I say, well, look at Google. They could not exist without it. Look at Facebook. They may not run directly with Red Hat software. Certainly there's no logo on there saying Extruding, but if it wasn't for what Red Hat and the open source communities had built, they couldn't exist. So that's the infrastructure I always am in, and when I have a choice, which is now always, I'm open source. Meaning I don't look at the commercial products at all from a licensing perspective. So I will cover that a little bit, which is why I chose the t-shirt that I did. Just a couple of small points. I mean, I would not categorize myself as an expert in 3D printing. I've been doing this for at least a couple of years with my own printer. Before that, I was interested in some of the modeling happening and how the control systems were there, but I thought the price point was too high to just mess around. Until some guy found a $250 / good quality printer that I started with a couple years ago. But I am not what I consider someone who can go in and tell you exactly, well, I have these 10 different types of filaments, I can tell you exactly the settings for it. No, I've got to do some studying and testing around to get that done. You will probably find that I have opinions about pretty much everything. I know what I like, but I also respect other people to know what they like. As long as there's no conflict and they trying to tell me what to do, I have no problems coexisting with other people. And I don't know when we met, Mark, but that might have been when FedLux started, which was back in the mid-2000s.
That general era, yes, yeah.
So we've been...
That's why I could not name this lug Fred Lug. The name was already taken.
That is true. So, why do I do this? Well, so I told you guys I'm into electronics. I have a fairly big lab now. I grew up over the last couple of years with normal electronics lab, from scopes to frequency generators and all kinds of other test equipment. and creating my own components from scratch. Right now, what I'm doing is that board you saw earlier. I want to set up a completely separate PSU, and now of course I can go to Amazon and buy one for $5, and it will power it. I want to do that on my own. So I've done lots of test designs, and now I'm creating the equipment to test those designs to actually make sure they work under load and so on. To do that, I need boxes. And while you can buy boxes, they're usually $40, $50 a piece. And then you start having to drill holes in them, and you make a mistake, blah, blah, blah. It's a lot easier to just do a prototype print, and with a piece of software to design a box with some holes here and there. And if you make a mistake, you adjust the model and print it in. So that's the primary reason I'm doing it. Another reason is that we always need trinkets. Something breaks, something happens, or hey, I just like Star Wars things, or Star Trek things, so I can print those kind of things out. But what even more important to me is it follows the open source principle. It means that I can share what I do with others, and they can lean on that. And right now, what I'm doing a lot more is leaning on everyone else's productions. Without open source, that would not happen. So to me, 3D printing is open source for physical components. And there are lots of people that don't understand what that means. They think that, well, if an artist creates an object like this, they can start printing it and having people pay them money and claiming it's theirs. No, it's not theirs. Like open source, just because I use someone else's code doesn't make that code mine. It's very important to understand that open source doesn't mean that no one has ownership of stuff. And that same goes with 3D printing. And that's a very strange line to draw for people who think that free means everyone just can go grab it and make whatever money you want out of it. So I say that I make money out of free software, but that doesn't sell software. And that's one of the things that takes a while to sink in. So the services around. You sell the packages, but the software is free. You don't pay right half the stuff you can keep software. Try that with Oracle, try that with IBM. The moment you don't pay for it, you have to give it back. And that's not the case with open source. So
what's the licensing around the 3D models that you use? Is it like Creative Commons, or what do they use?
So it's different from site to site. There are sites we actually have to pay the artists, and there are sites where it's completely free. And then there are sites that have both, where you can say, I only want to see the free pieces, or stuff like that.
Like, will they do like Creative Commons, free for non-commercial use, or things like that?
There are sites that basically state, and people don't read, who here reads the URL behind when you download software, it says, agrees with conditions. And you can click there and you read 20 pages. Who rates them?
Or even when you're using like Google to grab images, you can actually ask Google, these are the rights I want. If you do the advanced search, you can say free for commercial use, or like you can tell it, and you'll watch the images available
go from thousands to none, right?
Yeah.
One of the things that is important to look at is who has the ownership to what you're doing. And a lot of them basically states, as long as you're just using it for private use, go ahead, have fun. And most people go, that's fine, and then they go out to some place and put it in, and they get paid for the opportunity to speak, and they use the images that say they grab from somewhere. If that's recorded, you violated those conditions. So it's important to read the fine print when you take someone else's work. What I always do, and you'll see that later, is I certainly use other people's material, but I always critical. And that's just a common practice in academia anyway, to always make sure that you don't take credit for someone else's work. Yes?
What, besides Thingiverse, what are the other repositories of great stuff that's available?
So, I mean, people are making a living out of this, right? There are artists that basically, all they do is to create objects, that people want to print. It could be someone that makes Star Trek memorabilia, Star Wars memorabilia. They can make Hobbits, or Groot came up last year, was the most popular thing everyone was printing. And someone designs that.
How do they get around licensing if they're doing Star Wars or anything like that?
By not necessarily making it look exactly like. And that's the funny thing when you go into that. Everyone starts arguing whether it's the complete design, whether it should be this model and that model. And this is where you get the model and you can modify it. Right? If you want it to look like something different, you can do that. But these artists, to get money, to live, they sell those designs around. So you are allowed to use it for your own use, but you can't print and sell it without giving them stuff. But that's the way a lot of the world works, right? That if you're a company and you use someone else's service, you may not pay for their service up front, but when you sell your product, you pay them a portion of that profit. And that's the same for modeling. If you start a business and you start selling these things, all you need to do is pay the guy who created it. Open source doesn't change that. But it does mean that I can easily have someone that sits in Australia benefit from what I did. We don't need to be in the same room. We can do this all over the world, and as I will have, oh, no, I don't have that here. Yes, I do. Right. NASA uses 3D printers on the ISS. Hey, don't have that gadget? Let's print it. And I see this as, it was predicted to really take huge steps forwards in, well, a couple of years ago, but it's still kind of slow, and it's a lot to do with the materials that are cheap to get a hold of. Like the plastics are great, like you see here, but under certain loads, you can't use plastic. Like it has to be metals or something else harder, and that puts a lot more requirements to how, and it puts it out in most people's price range, but they do exist. So it is getting to be something that is fairly easy to use, and now it means you can go somewhere and say, wow, I need this gadget, and you can print it. Giving back. This is literally what turned me on to 3D printing. I did not want to put too many sites, but go to the enablingthefuture.org site. I was at a mega lab in Northern Virginia called Nova Labs. If you've never been there before, it's a toy store for children and adults. I mean, if I could, I would live there. I saw a day, we opened the door, and all of these preteen girls and boys came running in, all excited. Most of them was missing a hand or an arm or something like that. They were going to get the prostheses that had been printed that they had designed and that this group had printed for them. These prostheses, if you go to a doctor, you can easily be $20,000, $30,000. It takes a long time to design, and kids grow fast. So the rule of thumb is within a year they've outgrown it. These things cost a couple $100 to print. That is a game changer. So now the kids were running around with Superman things, or Superwoman girl, for girl stuff, or princess stuff, whatever that child wanted to design it as, whatever color scheme they wanted, whatever gadgets they wanted on there to play with. And whole groups, this is one of them, that all they do is print for these guys. When they're not using the printer for something, maybe commercially that they're doing, they print this stuff on demand. All the cost is film, and maybe a little bit of electricity to run the printer. To me, it's one way of getting back, but it just, that struck me as, wow, this is open source when it really works. So I make a lot of stuff. So this guy was supposed to have been with me. So yesterday, or last night, I came home late from a customer yesterday night, and I said, well, I gotta make sure it works. And he had a little problem turning, so I took the front apart to figure out what was going on, and then the wheel fell off. Turned out that the axle that I had, for some reason, I given up the last time I ran it, and needed to be reprinted, and it was too late for me to bring it. So stayed at home. That said, it's a fully functional RC car. I think it's a 1/10 of a scaled down version of the Formula 1 car. It's part of the Open RC project, which makes more than just one car, where they put all the designs out, and every component on there is 3D printed. Now the motor, of course, is not. But everything else can be 3D printed. So the wheels, the rubber wheels, so this is actually one of the wheels being printed that failed because someone cut the power. I'm not going to tell who. But see, we can have rubber plastic. It doesn't have to be that hard stuff. We can actually print all, and we'll get to that, all kinds of materials to make things that work. Oh, yes, sure. You guys come up here and look at it. It's not going to bite. I also have quadcopters at home, more or less in working state. I have one that basically just needs to be calibrated, but I haven't looked at it for a year or so. And that was one of the things that got me to realize I really need the 3D printer to work, because these guys break very, very easily. Crash into a tree, it's in 1,000 pieces, right? So being able to print the parts, except for the motors and the receiver, really makes it easy to go and say, well, I can actually afford making some mistakes. Already mentioned the IoT stuff, so I have tons of Arduinos, PICs, OLX, all kinds of other types of microcontrollers that I could make anything from cheap sensors and other kinds of boards to control from. Some of them do RC or IF communication. Anyway, that's in order to put those in a box.
Hello, Jack.
Sorry, that's fine. I use a 3D printer to make those. This is actually the printer in sped it up. I think we're 10 times or something like that printing. So one thing I gotta make clear: printing in 3D is freaking slow. At least in the traditional extruding way that I would say most makers are using, where we get a little piece of plastic and move it around layer by layer. It's meant for prototyping. It's not meant for mass production. There are printers that are much faster and meant for higher levels of production. But in the end, nothing is going to be as fast as the stamping machines that basically has a template, puts in a layer of plastic, and then you have the component. And that's the way most of our stuff is made today when we go out and buy it. And they can make thousands of those a minute. This took 2 hours to print. So, and that was a quick print.
So since it's going layer by layer, is there any limits to what you can, like, are there certain designs that you can't realize with a 3D printer?
There's almost no limits. There are some technical limits you're going to have. Like the more fragile the print, let's say the more, you can't make two pieces that are not connected and one hanging in the air, right? That's kind of typical. So if there is a connection, technically you can print it, but you may need a lot of what we call support material to be generated. I'll get into how that works in a moment. And the more you need of that, the more fragile and more chances are that that model won't print correct. So there are different types of printers, and I will get into those, that make certain printing of certain types of models easier because of the way they work. And I was really hard at figuring out, should I actually do this talk about software and just ignore the printers or not? And I decided just to do a quick overview of the printers and how they work in order to make that software make more sense, what we have around. Oh yeah, fix up all stuff. I cannot tell you how many things I see posted online where some guy says something broke in my refrigerator and I fixed it by just printing it. Sometimes you can go out and someone will go design the gadget and you can just find it. And sometimes you go and look at the gadget and say, oh, that's a simple piece, I can design that.
Have you guys seen the Photoshop? Basically, one of Photoshop's tutorials has a camera that has an app that takes like 6 or 7 pictures and then translate that to a 3D printer.
Yeah,
I think that's it. Yeah.
You have some. It usually takes more than that, but you can actually take and convert pictures into models today. And you can make something where you just take your normal phone and take like tons of pictures around it, and it will try. You still have, there's a lot of requirements about what needs to be around that model when you take a picture for it to do it, but it will get a very good idea of how that initial model needs to be done. Just note that you still have to go and touch up on it stuff. It is not as pretty and as efficient as creating the model yourself, because you can't really control how all the polygons are going to be lining up. There's a lot of work in cleaning all that up afterwards.
So one thing I saw a while ago, maybe it's too much detail to make it work, custom action figures where you take pictures of a kid's head and then you put it on like a 12-inch action figures. Is that something you can print, or is that too small or detail?
People have so people do lithographs. They're taking pictures of, let's say, of a family and printing it in a thin film of plastic and putting it in a lamp with a light between it, and when the light goes through it, you can see the picture. Right. So when it's outlined, you can actually see faces because you can. I mean, an eye socket is a little further in, and because it's a lighter or darker, there's more or less plastic, so you can see a lot of details there. And that's software that will take a picture, and I'm going to show. I'm not going to do a demo of that. I didn't plan to do that, but there's software that can look at a picture and take a color map and convert it into a bump map, and that now becomes your height in whatever you want to print. I gotta say that one of the things I learned very early on is the last point here. You find yourself wasting a heck of a lot of time just staring at the print. First you start staring because you know it's going to go bad. There's something that may not be aligned right, and you're just waiting for it to fail to see what failed so you can fix it. But it's extremely hypnotizing. Hypnotizing, there we go, thank you. To just stare at that thing, and as it keeps making smooth layer after smooth layer, and you go, wow. Anyway, all of a sudden, 20 minutes has gone by just staring at that thing.
Is there any issues like getting the layers aligned? Like, is that part of like the gearing and everything in there?
That's one of the things that makes 3D printing different printers. More expensive printer makes that much easier, but the very cheap ones, that's a manual process, and that is where, as you're a beginner, you're going to make a lot of mistakes. So I'll get into some of those things too as we start talking about the different printers. So what is 3D printing? What is typical 3D printing? So the typical hobby guy like me has a printer like this. This is the Prusa i3 M3, which is the latest model. Right now, I probably think it is the most popular and most praised 3D printer out there. Prusa is 100% open source, which is really why I chose them. So everything they do is published. They have probably the best guides ever written for how to do 3D printing, including putting this together. It's all collaborative. So you read the guide, and if it's something that's not right, you tell them what's not working, and they will correct it. It's not like a wiki because people make stupid errors. But you collaborate around making these guides better and better. And people say, this was not easy to understand, but if you wrote it like this instead, and then two days later, you go in and all the guides have been changed. In 5 different languages they can maintain them. So it's not a small operation.
I wonder what the way back was for that.
Yeah, so my first printer was a company up in Maine. And their description was like a Google Drive that someone had put a document together that was not even halfway current. And not most, but there was quite a lot of it that no longer was true because the model I got was not 100% what that guide was made for. So you ended up having to be on forums to say, well, yeah, you have to do it this way and that way instead of doing it this way, and everyone was complaining about certain sections were completely wrong in the guide, or said if you do it that way it's much harder, if you do it this way it's much easier to get it working, etc., etc., etc. Going to the Prusa setup was just a huge difference because it was all, I think this guy has grown to 80 or 100 people now, selling printers all around the world. And their i2 printer is now setting the standard for all the clones out there. And it's open source, right? So the idea is that you can make it yourself. So everything you see in the printer, including the metal frame, the specs follow. If you want it CNC, here's the spec you send to the CNC guys, and they will make it for you. But the typical printer is additive, like meaning it adds layers by layers by layers. So it starts from nothing, and then just keeps extruding out a little bit of a filament over and over again, layer by layer as it keeps going up. So that's called fuse deposit modeling, or FDM. And fuse simply means it melts the plastic first. And so one of the tricks is to make sure that plastic cools at the right moment and hardens. Not too soon, because that way it doesn't really get to be part of the piece, not too late, then it starts melting over and kind of float over what it's supposed to do and loses some of its height. 3D printing is nothing new. No, I did write like late 1980s, and this printer type is from the late 80s by Scott Crump. But it really started early 80s. But it kind of had the generations before that is a little weird. but in today's standard. But if that set the standard, that's what came out with G-code that runs the printers and all the stuff behind it. Most printers have 3 axes, and X, Y, and Z. The X is what goes back and forth. The Y is in most printers, and not all of them, is the bed moving back and forth. And Z is this crane here going up and down. And it starts all the way down, and then it starts with printing layer by layer by layer as it goes up.
How big? Like, does the cost go up as you get to something that can go higher or more movement? Or
so the bigger the printer, the bigger the motors, the more precision do you need, and the higher you build, the less stability your model has. So you need more grip and all kinds of other stuff. You may need support if you get very, very high up. But we have 3D printers that make houses. They basically extrude concrete.
Wow.
So size is not an enemy, but it means the 3D printer gets a different design when we get up to those big things. So now 3D printers that are bigger than me that can do stuff. But usually they extrude a lot more plastic at a time, and they're not making very fine objects because of that. But there's almost no limit to what I can do, as long as it's a single piece. And a lot of times, if I have multiple pieces, you print them individually and you just glue them together and you're done. Or use a heat gun, or if you use certain filament, you can use that as well, and that will fuse them together too, because that is a chemical that the plastic will react to. So it's fairly easy to make very big things. People have made, if you're into cosplay, make complete customs for people. Face masks and coming in as Iron Man or whatever, all printed on 3D printers that are no bigger than plate by plate by plate by plate.
The new stuff can print they can print fabrics.
So I'll get into these filaments in a moment, but yes, there's also no limits to almost what materials we can have, including metal. Some in will even print metals.
What's that mean?
So here is a very quick overview. I will get into those in a moment, but so we are down here, and that is the most popular one. A lot of what you see here is really meant for industrial only. And you see the machines, they have huge lasers, they have some nasty chemicals inside of them, and they're usually very big boxes standing in a bigger room somewhere. Not for hobbyists, by far, but if you really are into an industry where you're creating a lot of things, could be boxes for these guys, that would be what you would need. And they will just stand there and print day out and day out. Maybe the same thing, maybe slight variations so you can test out what works best. So the stereolithical printing is very, very fast and very, very accurate. And what it basically does, it has a container of resin, which is basically a box on a piston on the bottom. And a laser goes down, and whenever it hits in here, it hardens the resin. And so it basically functions as, just like the normal 3D printer we have melting metal, it just uses the laser for point to point to point to harden the metal in that layer. And then as it finishes up a layer, the piston goes down a little bit, and it takes the next layer on top of it, as the resin comes on top of what it just hardened up. And the advantage of that is that you can actually make models that are very fragile and have very few connections, because the resin helps holding things together while it prints. Whereas in the traditional 3D printing, we have the FDM, gravity is against it. Right? If you have something that is bending over like this, and you try printing over here before there's something you can hang to, good luck. Ain't gonna work, right? These are not only expensive, but this stuff, the resin, is freaking poisonous. So this is stuff where you have to have white ventilation and white protection just to touch this stuff. So it's cool, but because of it's a laser, there's no mechanical movement on it, and a little mirror for the laser, it's extremely fast. This is almost the same, but without going into necessarily how it does it, instead of printing dot by dot, it prints layer by layer. So if you've ever been in an old data center seen light printers, where it printed a whole line of text in one go, it didn't have a little head to rain over. That's the same idea here. You can actually spread the light out correctly on the whole layer at once. So imagine all you basically need to wait for is the resin to harden enough so you can go on. This is the model that I'm using, and I think most of the people that I talk to are using online. Again, we have a little head running back over and over and mix these layers, and if you go very, very close, this is literally how it looks. They are going to be little round things, and if you keep the heat up enough, they will melt so they're not round anymore, just before they harden. And then they become flat. But they are coming up like little round balls. We have something called selective laser sintering. I've never really used that, but instead of using resin, it uses powder. But it functions in the same idea. It is the moment we apply heat to that powder, we harden it up. And this literally can print stuff without any support at all, which is kind of amazing to me. So I can print that overhang by printing the bottom first, and even though there's nothing underneath it. So that means I can pretty much send any kind of model I want to. And I say expensive 5,000 in 3D world. I would say that's in the low end for commercial printers. But from a hobbyist perspective, I know very few hobbyists that spend that much money on the printer. Well, initially. Once you start upgrading it, you may end up there. This is very important to me. All these chemicals they have. Some things allows you to reuse what's in there, like the resin. You can, in most cases, reuse what's in there, just fill up a little bit more to a certain point. But the powder, because it's not just where the laser hits the melts, there's also a little bit beside it that gets corroded. You basically have to empty the whole thing out. So that's a lot of waste. This produces a lot of waste too. Because this is what worked, although these are examples of things that broke when I printed them right. So this was almost done. It was like 10-15 minutes from being done, and well, long story short, something went wrong, and I have to basically print it all again. So that means that this is wasted plastic. Oh, sure. I would say when you start out, you're going to have a lot more waste than you're going to have goods then. So there's a whole new market for for creating a machine that basically tears the plastic apart, makes it into what they used to be in polymers, like little small plastic cubes, and then puts it to a melter that makes the filament, which is what this is.
Like recycling it a little bit.
Yeah, so you can make your own, and the cool thing about that is if you start putting different colors in, you can make all kinds of cool filament. So I brought this because this is probably stuff that I have to throw out. This is one of my oldest filaments, and filaments come in different qualities. This was definitely cheap when I bought it.
What material is that one?
This is PLA.
PLA.
But over time, they will actually get moisture in it. And that means when the printer starts printing, it will get some weird malforms of the extrusion that looks very strange. And in this case here, it's so bad that it actually will stop clog up the extruder.
The plastic gets old? That doesn't make sense to me.
It gets enough moisture in it that it makes it hard. So some people actually have ovens built just to get the moisture out of the filament.
Keep past it.
Yeah, go ahead.
Can you store it with like silica or something?
So that, lots of ideas. I saw one, was it 2 days ago? 2 days ago. He went to, I guess, Bed Bath & Beyond, something. Got one of these big black plastic boxes. And he got a rod, put it in the middle, cut 2 holes in the side, and then he put the filament inside, like in the middle of that big box. And he put hat lid on the bottom. Hat lid absorbs moisture. And he puts the lid on it. That's the way he stores the filament. And I go, that not only doesn't it use energy, but that's pretty amazing. Like when you're not using it, it's like when you buy the filament, it comes in a vacuum with one of those little moisture packets inside of it. It's the exact same principle, just on a bigger scale. And I thought, well, that's not only cheap, but it's something that's maybe worth emulating.
Do you have it on a spool, or you could like open it up and it just...
Yeah, so you can make a little wall hole, on a spool holder, so you could literally just take the filament and feed through that if you want.
Yeah. How do you tell that it's just more stiff? Is that how you tell that it's getting older?
No, you try to print with it and you start having problems. Selective made the laser melting, which is like a combination of the layer structure and the powder coating. So basically, it makes a little layer of powder, and then it comes over the laser afterwards, a little layer of powder, and a laser over it afterwards. So we don't have as much waste. And they tend to be like refrigerator sizes, 2 or 3 refrigerator sizes for the basic models that I can see. They're not cheap, and they're not small. Electric beam melting. Instead of using laser, well, it doesn't use a noble gas. So when the laser runs, it gets very, very hot. So in order to do that, we use something to prevent things from burning. And I use gases and something else. Instead of using a gas, this one uses a vacuum to deal with that. Again, it's a laser, it's large, it gets hot, it's expensive. And it still uses the powder coating. The last one, which I did not know about, this looks like it is actually a prototype that has been done in Sweden. But it's using a laminated object. So basically, it has, instead of a filament, it has a spool of materials that slowly goes over, and the laser then basically types out. It looks like an old type of typewriter if I look at it using a laser light instead, and gets the material that way. The cool thing would be that this could be moved maybe sideways. Now you can have different materials and put them in, different colors or different strength and whatever when you need it.
So there's holes in the sheet on the other end then, or?
No, basically the laser goes in, the sheet goes over, it's full, and when the laser hits it, it melts it, and now becomes part of that model, and it disappears from the sheet.
Is there a lot of waste with that one?
Well, so that would be one of the things that I would be concerned about. But this is, I think they just started a couple of years ago. But this spool here will certainly have a lot of holes in it, yes. So the idea would be that you probably have to run that through and get it all off, and then make a new spool, and then you can use it. It's a lot more energy and more machines you need. But the difference is that this material is not poisonous, and it's very cheap to get a hold of. So maybe the waste from a financial perspective doesn't matter. Ecological, it may not be the same. And the last one I think is the binder jetting. And it uses 2 materials to go in. So it uses both powder and a special agent to actually make the model much more hard than the other models would be. So we can now probably use this for more types of machinery, even do ceramics and glass and stuff like that. So we can start making some stuff that is really robust and can be used not just these plastic models. I could spend all day just talking about filaments, and I am not an expert in it. But one thing you learn very quickly is that you start looking at all the plastic you buy, and you start learning to read the little codes in the back that tells you what type of plastic it is. And that's a lot of times when you see these names in uppercase, that is what you will find in the back on that little triangle that tells you what plastic it is. The most common plastic out there is PLA, and it's probably the most forgiving to print with, but it also has an extremely low melting temperature. So, well, first of all, that means it's easy to print with, because you don't need to have a very hot extruder and very expensive stuff to do that with. But it means that if it's anywhere close to anything hot, it may melt. People have them in their cars, and they come out and go. Everyone remember the old LPs, albums, the old vinyl records? Put them in a hot car, see what happened? I lost records that way.
So Peter, I'm big into Legos. ABS is the plastic.
ABS was the, I would say, high-end plastic for 3-4 years ago. It has a much higher melting point, 240 to 260 degrees centigrade. It also means that a heating bed that you have needs to be much hotter. Usually, that's about 100 degrees centigrade. It means that the printer quality has to be much higher to get a model out. However, it's usually a lot finer, a lot more robust, harder to deal with, harder to kill, basically. And you can use it where there's heat involved, at least to a certain degree. So the models you get out, the plastic you get out of it, even if it's kind of thinny like this, is actually pretty robust. This is PET, the one beside it, but those two are almost the same, except PET is a little more forgiving than ABS for bachelor. So I can use cheaper equipment to print it and still get hard materials. And that's why this is winning out.
Which material did they principally use for the kids with the prosthetics?
That will be ABS in those cases, because it's harder. And it will allow them to be outside, meaning indirect sunlight without running the risk of being melted.
What's that red one?
The red one is PETG, actually. So this is actually this is one of my own designs. I was trying to make a holder for a anniversary gift for my my wife, and it looked great on paper, but in practice it turned out that didn't work. But you don't know that until you made it, so I still have it. So PET is a material I think I will prefer, but it's not as easy to print with as PLA, but it does produce some fairly robust prints at lower temperatures, which is pretty cool. I cannot say I've done all these. One of the things that I want to get into is the nylon. Those are a lot harder when they come out, and you can make some cool stuff looking. Wood filament is something people have used for a while too. It is not. It looks almost like wood. It gets the same kind of color thing when it's done, but it is usually ABS or PLA based. That wheel that I sent around earlier, the rubber one, is made with the flex material, this guy up here, and it is. Let me put it like this. When I saw people complaining, they were usually the guys with the cheaper ink printers, and I mean like maybe $100 or so for the printer, or maybe $150. The extruder has to be of a certain caliber to deal with something that is rubbery, that is not stiff and can't just be taken by a little simple wheel that pushes it through. And if you don't set it correct, if you don't have all the settings in the printer correct, or in the setup that you do for your modeling, it just gets to be a big mess. And one of my initial mistakes with my wheels were to have it at a too high a speed, and then all of a sudden I would put down and saw the filament coming out all over the place, because it was just pushing too hard, and instead of pushing the filament through, it just bent. So those are the kind of things that you need to learn. But just remember, when you look at this is just what's out there currently. If you look at professional plastics, sometimes they are a combination of these things. So this is often when they make plastic, they come with polymers from different types of plastic and put them together to get certain characteristics. So that's something engineers knows about. It needs to be robust, it needs to be a little bit flexible, and need to have so much of this and so much of that, etc., etc., etc. They also have multicolored materials. I mean, the same strand changes color. So you can make some very interesting effects, like printing a vase that goes from red to green to yellow all the way up automatically. Yes, sir.
Which of those can you use unvented in a residential setting?
PLA I have done very much unvented. I am not venting my ABS because you can freaking smell it. And most people try to vent it. But anything you melt, it is plastic. You know, there is going to be an odor. If you have a very small room, I would vent it. Often what people do is they put the printer in an enclosure. And some people just use a carbon box. It doesn't have to be something fancy. But they fully enclose it when it prints, which also takes away from this idea that you have to stare at the print as it goes. Can't go through that. And they can then put a filter on that and a small fan, and then get rid of the old stuff. It also means that it's easy to keep the higher temperatures and not keeping the heater going on all the time, because it doesn't cool down as fast. So there's a lot of reasons for doing enclosures, but often when you deal with all these types, particularly if you print 24/7, you will have enclosures. Or you will be in a room that has a heavy ventilator going on, because this is plastic and it is not meant for humans to breathe. So, here's a very quick summary. And like I said, when I did not come up with this list on my own, I always put the source on there. So a 3D printer basically has a frame. That frame, like 2020 extruded aluminum, is very typical use for the low-end ones. That was what I built my first one with, and it can be extremely steady. I mean sturdy, sorry, not steady. we have a printer head that moves. Some people call that a cartridge or carriage. Some printers even allow you to exchange the head. Right, so you can have kind of like a CNC machine where you can change tools out easily. Some it's like, you know, if you want to take this apart, you can, but you really have to take the machine apart to do that. We have the head or the nozzle that actually extrudes the filament, and that's associated with the actual heater that makes the filament extrudable, because it comes out hot, and it comes in hot like that when you start. That nozzle comes in all kinds of different sizes and qualities. Typical, we have 0.2 millimeter or 0.4 millimeter is what people will be using in most cases. And yes, everything is metric. One thing that happens when you want to share across the world is everything becomes metric, because no one else does but the US does. And it's freaking easier with millimeters anyway to figure out instead of 3/4 inches and 5/6 and whatever else the US comes up with.
Base 12 sucks.
Yep, anyway, so I lost that argument at home. But anyway, there's a built platform or bed, and that bed is typically heated. This is where most people fail with electronics, because that is what draws the most power on your printer. And these boards, I will get to in a moment, some of them are so cheap that when you draw full power on them, they claim they can take 20 amps, but they can't. So you will often see pictures painted with these guys, because you can get these a dime a dozen, but this whole thing melted because there's too much current. So if you handle those, they don't like static electricity, so just be careful with keep them on the beds. But the heated bed is what keeps the print on the bed as it prints. It is what makes most of the adhesion happen. And it has another thing. What happens to plastic often when you heat it up, or what happens to a lot of materials when you heat it up? They shrink. Just a tiny bit. Right? So, but enough of that shrinkage can mean that you can get certain things of the print can all of a sudden lift from the plate, because there's less materials, so something's going to give. The heat ensures that shrinkage doesn't happen until you're all done, and then everything can shrink at once instead of one corner at a time, and you get all these weird things. So those two things are what the heating is for. You usually still have some level of adhesive on the bed, depending on what you're printing with, to ensure that it stays put. And I would say this is where my old printer really had a problem, because I needed a lot of adhesive, and I broke several glass plates because it was so good as adhesive that I couldn't get the damn thing off. You need stepper motors. If you get into any kind of IoT, Arduino programming, that's going to be one of the sessions you're going to have, is how a stepper motor works. They need a special circuit to work because of the way the cores work, but it means the motor can be very, very fine, do very, very fine movements, like several fractions of a millimeter per move. And this is one of the things you have to tell the software, is how many steps does it take to make a millimeter. Some is just 16, some are more, and that's what the printer uses to calculate how many steps do I need to go out if I need to go this many millimeters across. We need some electronics, which is what you're looking at as it goes around here. That's the RAM board. I think that's 1.4, which is probably the most used for all i2 type printers. It works on an Arduino Mega. It's just a board put on top. You put a driver for each stepper motor, which is not on the board right now, and basically just hook everything up. And the firmware goes into Arduino like you program the Arduino with anything else. So the source code is there. You can look at it, and a lot of people. Marlin is probably one of the most active upstream projects. And I'll get a little bit into that in a moment about how the open source actually works with 3D printing and making this better. The firmware is pretty much, I think, what sells a printer or fails it. This is what interprets the electrical signals coming in. That tells the printer how do you turn this command into a movement. And if that's not precise enough, if that's not easy to use, no one figures out how to use the printer. If it is very, very basic, it means it has nothing, well, it doesn't have any electric protection for once. That's, overheating protection or underheating protections and other things that could cause very big mechanical failures is sort of, to me, a must. But some of these are so bare metal that they don't even have that. And unfortunately, it's disableable, so you can turn it all off, or you make your own code with a single flag, and then you can really get in trouble. Another thing that might be missing is calibration. So how far? So we're talking about fractions of millimeters, and being able to do that by your eye or with a little piece of paper and stuff like that, it's not really precise enough. It's going to get in the ball game, but it's not precise enough. So if you don't have a feature in the firmware to say, hey, go around, measure the actual distance, and make subtle software adjustments to what the reality is compared to what the physical world is, then you get bad prints out of it. And finally, there's the software on your computer to actually create the stuff that you want to print. And there's two types, I'll get into that, of software that we want to create on the computer for that purpose. You also have software that sort of works as the firmware, although not really. It wouldn't work without the firmware, but it does do a lot of the monitoring and can say, well, I don't care what the firmware says, but I can see the heat is too much and I'm going to shut it down. So how do we normally print? Well, we start with an STL, which I will get into in a moment what that actually is, but that's sort of the source code that most modules are made in. That tells basically all the movements that is very layer of this, or it goes to this dimension. It makes polygons per layer, basically. In order to get that into the printer, we have to turn it into the language the printer understands, which is called G-code. And that's a basic language that basically has commands like move the x-axis to this position, move the x-axis 5 millimeters this way, and move the y this way, or change the temperature to that. Very, very basic commands. So in order to do that, we do a process called slicing. And that slicing needs to understand how your printer works, what options and what parameters it supports. So it takes that model and says, given that printer size and given what it can do, this is the kind of commands that I need to send to the printer for it to work. So my printer may be different than yours, meaning the G-code you're using is not the G-code I'm using, which is why we don't distribute the G-code files. They're very specific to the machine and very specific to my choices. Maybe my printer can write in 4 materials, and I have them in specific ports and not in that box, and my G-code then has those specific components in there. There's no variables in G-code whatsoever. They're all fixed values that are created when you create. But that's the language the printer understands, and that's what we print. So there's two ways of getting the G-code to the printer. Most printers has an SD card. So put it on an SD card, plug it into the printer, and you can push the button on it and find the file and say print that. Or we can use the software on the computer itself with a USB cable and print it out that way, which basically just means it sends the G-code out over the USB. There's actually a third way, I'll get to that in a moment, but we can set up a server that can control multiple printers called Octoprint. But it basically does the same thing, just sends a stream of G-code to them. We may print with a lot more than just one material. That's becoming pretty popular. When I started, that was like, wow, you're rich, because that's an expensive setup. It's still a little pricey, but it's getting to a price point now where I think we can actually see more and more. And what it allows us to do is not only combine material types, but also combine colors and all kinds of other stuff. So instead of printing a model and starting painting it when you're done, you can now print it almost with the right colors, assuming you have all the colors in the filament that you want. Some of them can mix the filaments and make a new color out of two colors.
What's like the setup and cleanup time? Do you have to clean the heads when you're done with the job? Do you have to do...
So my old printer was pretty long for my cleanup job. I mean, particularly when something goes bad, you have to take it all out to clean it up. Right now, most of my stuff is, so with the Prusa, one of the things that I really love about it, they made a flexible plate. So I talked about that glass plate breaking. So the current printer doesn't use a glass plate. It's a sheet metal that is bendable, and it's magnetically attached to the bed, to the heat bed. So when I'm done, I just take the sheet plate off the printer, bend it slightly and everything pops off. Meaning that's how fast I get things off. Then I wipe it down with a little bit of alcohol and I'm ready for the next print.
Like the print head itself, you don't have to clean up if you're using this.
Once in a while, you may want to do that in particular if you've had something, but the printer, again, this is why I love the cruiser model. When you change the filament, there's a function in the firmware, and it will actually extrude enough out to clean out the extruder, and there's specific filament you can do that actually goes through and sort of scrapes out whatever residue that might be in there. At that point, I would actually consider changing the extruder. There's a little, what's it called? There's a little pipe in there of a special material that's very heat resistant. Shoot, can't remember what it's called. That can get damaged. And in some cases, if it gets damaged, it gets too big or too small and can interfere. And particularly if there's other kind of dirt in there, can stop the filament from going through. And you just need to get a new little pipe.
Have you seen the size changes in the filament heads? Because I've heard that the sizes have gotten finer and faster recently. So how's that outlook for you? So the filament itself, when it all started in 80s and 90s, when it wasn't really for hobbyists, it was 3 millimeter filament. That's 1.75, which is the most common today. But the heads themselves can be any size. Right? Just because my filament is that size, the only thing the filament size does is to allow you to actually do a faster extrusion to get, the thinner it is, the more I have to extrude through to get the same amount of plastic. So a very thick one, I have a very small movement, and I need to be able to fine control that motor to very small steps to put fine amounts of filament through it. And with a thinner filament, if I need a lot, I need to have a fast extrude. And often we want to actually get them down to be as slow as possible because it is a very fine movement that we want to do. On the head itself, I can use the same head on both types of filament. I just can't push as much through a very fine one. But the finer I make them, the slower they get. Because I can have less and less plastic out at a time, but the finer the details I can create. But my question, excuse me for my poor phrasing of that question. The extrusion rate, how fine these things are, have you noticed it? Because look like you've been on this for at least 10 years or so. Or maybe like 5.
3, maybe. 2.5.
Do you see any trends that are coming up? Like how fast things are going to be starting to be printed soon?
So I would not call that. So the extruder is what is responsible. It's the motor that is responsible for how fast the filament goes through the machine. Yeah. And there's all kinds of extruders out there, but in most cases, what people do with them is try to gear them down so they can make finer movements. That is not really what sets the criteria for how fast you can print. It's how sturdy is the machine. Because if I have a lot of rapid movements that are very fast and it has to stop immediately, that's a lot of force that you have to assault, and then all of a sudden the frame starts wobbling. And now it affects the whole print. You don't want that. So when you start tuning your printer the first time, that's one of the things you need to look at is what are the max speeds that I have for movements, both for the fast movements where I'm just moving to a new position without printing, and the slow movements that I have when I print, and then depending on what I'm printing, there might be different speeds depending on the details that I want out of it. And that all comes down to the frame you're using and the type of motors you're using for those movements and how you can control that. So if you're using it with a what do you call it? A lead screw, for instance, you can actually speed that up quite a bit, but the motors have to be really beefy to do that.
My question is, what do you think the outlook is for the next 5 years? Do you think it's how fast do you think they're going to start to be improved?
They're getting faster.
What's your take on that?
I mean, in general, they're getting faster. And that's also because of the way we learn and we can come up with better materials for frames. But what I think might change is that right now, the type of the FDM type of printers are the cheaper ones. And given that they have to print a dot at a time, basically, a piece of plastic at a time, that's what takes up the most time. As I talk about the other printers, they can do it a lot faster. And if you want fast, that's where you want to go. And if I had to print out several prototypes a day, or boxes like these guys may want to do, yeah, I wouldn't have a little printer like it. Or they would end up having a whole farm of them, which some companies do, because they're cheap to create. So it doesn't really matter, it takes 2 days to print, but they have 15 of them or 20 of them, and they just print all the time. So that's the way people get around that. And it's just a price point for the printer. But yes, they're faster today than they were several years ago, and that's partly because the prices of controllers and motors and all that is coming down, so I can get bigger, beefier things without sacrificing other stuff. But in the very cheap printers, that's what you get, is you get a motor that can barely move it, but it does work. But it will work on slow speeds. And that's the way I saw it. And I go, it doesn't really matter that this little gadget takes 3 hours to print. I think this guy, when I printed him, he made on the old, it was on an old printer, this is probably an hour's print. And because of the movements I had to do. In order for it to be fine, I had to slow it down. Otherwise it gets all anyone has seen him? I grew up with this guy. The Linear is an Italian cartoon. He never speaks. Well, he speaks, but it's a gibberish language. It's the most angry cartoon guy you've ever seen.
Oh, it's like the head of the Little Caesars guy.
Yes. But he talks to the cartoonist, and that's what the whole thing is. And it's like little 2-minute strips of different cartoons. Anyway, this is what you can do. You can print out stuff that you come across, right? Talk about this. So G-code. So there is actually a NIST standard for G-code, numerical control language. It wasn't meant for 3D printers. It was meant for CNC machines. And it's a very basic language. I wrote a couple examples of some commands down here. That is all ASCII based, so it's easy to see what's going on. And if you do this a lot and you do a lot of debugging, you will come to know what those commands mean, all of them. And there are a ton of them. But those are basic ones. It basically says go move the z-axis absolute to the the z-axis to 0.25 millimeters high. And the other one is relative. But basically one way of doing this. Right? So it's a language that has tons of options. And today these controllers actually have some level of logic in them. So they have variables. They have their own memory store. So there are certain parameters that you can set up in the firmware that you can all control to firmware to the G-code too. That could be anything from setting the temperature of your extruders to how many steps does it take of the motor to move from here to here. And that all is stored in firmware.
Does the firmware control how fast it goes from
Yes.
A to B?
Yes.
So you don't set that. Can you change that?
You basically set, what the firmware does is convert the command into electric pulses. And that controls how fast the motor goes. But in most cases, what the firmware wants to know is how many pulses does it take to move in 1 minute. And once it has that, there's another command that says how fast do you want to send that stuff. It doesn't have to be a parameter stored in firmware. So what the first thing that happens is when you send the G-code, the first part of the G-code is basically saying, I want to move it so fast. So what the printer does is say, well, I need to move it 200 clicks. And I need to do that in half a second. X number of clicks per milliseconds do I need to send. And then it does that. To move it that fast. So that's the firmware's job to do that. And there are movements where I want it to be fast. Like I want to move from the extreme right into the middle where I start. That's just a movement I'm not printing. I can do that very fast. But if I'm printing, I can do it only slow. If I'm printing the outer perimeter, I usually want to be much slower than inside because that's what I can see. So I want that fine. I want to make sure the plastic actually gets time to really melt and become very fluent with the outer layer so you can't, like on this tracking, you can barely see the layers between them. Because the outer layer is printed that slow compared to everything else. If you compare that to something like this, and again these are two different printers, you can actually see the layers in the script. What you also do sometimes, if you really want to have a model that you use for something, you will use sandpaper. And you will put some kind of a lacquer on top of that to make it clear. And make it robust to deal with sunlight and all kinds of that stuff. So this is all about open source, right? The 3D printing movement would not work without open source. This is how it really took off. It wasn't a single company that drove the whole thing. It was a community of software guys that worked together, and some of that was people working for certain companies to make 3D printers, but the biggest part of the community was just people interested in 3D printing. So they used that same idea we have about the traditional open source that we, for how many is familiar with the whole story about open source, how it did, but the idea that Richard Stallman started was based on accessibility. Right? Being able to actually start his own projects at the university was prohibitive, very expensive because of those sign boxes and everything, those idea boxes they had very, very high licenses. And his philosophy basically did not allow him to accept that. And out of that came the idea of open source. Long story short, he wasn't successful getting to all the stuff he wanted, but he did get a compiler done through T-Man, who actually works in Red Hat. And we got a few other components done that was enough for Linus Torvalds to go in and create a Linux kernel. Without that compiler and a few other basic tools that was all available for free on the GNU, we wouldn't have had Linux at all. That whole ecosystem started because in the mid-80s we started getting all the universities connected online. Right? So they can all talk to one another. You now start sharing code without having to move a tape physically between them all. And when the internet really took off, if you look at how Linux started out, and that was the use groups that basically started exchanging source code a lot. And when you look outside of the mechanisms of it, it was a lot of people collaborating around the same code. And that's how the code we're looking at, and we're going to look at a little later, are all going to work. All that code came out of collaboration. It's all fully open source. It's used by commercial companies when they sell the printers. When they don't sell the code, they have to provide the source code for the code they have in the printer as part of the open source licensing. But that's not what they're selling. They're selling the whole design of the printer, the support, everything else around it. And without all of that code in there, that printer would work. And they don't have the R&D to hire all the people to create that at the same quality. So it's a lot easier for these companies to work with the community to go through to create workable objects and so on. I always talk about that the GPL doesn't mean we don't own our stuff. You can't take the code I create under open source and code it yours. I can't take yours and make it mine. But I can add to it and say this portion is mine, that portion is yours. And now you know why Red Hat has lawyers, because when we buy a company and they're all proprietary, the first thing we do is open source the source code. And that means going through all of those contributors and making sure that they either allow us to convert into an open license that they own, like a GPL type of license. If they don't, we have to find a developer who knows nothing about that code already and ask them to create the code from scratch. It can take years to open source proprietary stuff.
Yeah, the interesting thing too is the economies of this stuff. Michael Tiemann, I'm not going to take up the time, but he tells some interesting stories. But basically, it comes down to somebody who's interested in your project can go into the source code, fix one bug, and never contribute again. Mm-hmm. You can't hire people in a model like that. It's just too expensive to bring people on board into your company, and But that one contribution solved the problem that guy had, but it helps everyone. And then when you think about just the aggregate of that, all these tiny little contributions make things better and better and better. It just scales so much better than
You have the whole world. You don't have to be in an office or anything else to put out there.
Now, I think there's still an art form to getting the community involved. There's a lot of folks that create open source. They create software, throw it over the wall and say it's now open source.
It doesn't make it open source.
But there's no interest in it. There's no community around it. So it's just a pile of bits, that one or two people ever worked on. So
and both those guys are working for the same company. Yeah, I see.
So a lot of companies will claim their stuff is open source, but there's really no community that's actually behind it. So
they're taking the rise of GitHub and how when you start sharing your code there and bouncing things around.
So again, GitHub, SourceForge, these are great locations for things to get accumulated, but at the same time, there has to be a robust community behind it. So if you go to some place and there's one or two committers and no one's really checking things in or no projects are forked, these are good indications that this is really just a niche thing that only has a very small.
Or it hasn't been changed for the last couple of years or something like that. It should
Exactly.
also be a big warning sign. And there are actually sites out there that will tell you who's contributing to these upstream projects, either by company or by organization, and how often and so on. So you can get a very good idea that you very quickly find that communities are not created equal. And that's also the bad side of community. Like what is popular today may not be popular tomorrow. And it takes very little for the community to change idea of where they want to put their time.
So the company we work for, Red Hat, they've done a really good job of helping foster communities around open source. Yeah. It's not just the fact that the code's available, but
we got
you
people
draw people.
hired. All they do is build a community. They're not working on any products that we're selling. They're working to enable community to work. So they may go around to meetings like this and help people get started, figure out what resources there's available. How do you actually, talk about the type of technologies they can use to get their community work. Just from an organization perspective, they may go out and actually be a representative of an upstream project that Red Hat may not be using even, and talk about what they're doing, but they are fostering a community around open source, and that's what, without that, Red Hat wouldn't exist. Open source is what Red Hat does from end to end. The last statement there, I use that all the time, and I think that comes from the Cathedral and Bazaar, standing on the shoulders of giants. And that's the way I see open source. I could not do what I do today by any means if there had not been all these huge, impressive minds coming together, creating the foundation for what I'm doing.
You guys familiar with the Cathedral and Bazaar? There was a series of essays that were collected into a book by Eric S. Raymond. So he's one of the proponents of he coined the term open source.
Yes, he did.
But it's a great book to read because it's all about sharing economies and how this model actually functions. So it's an interesting book called The Cathedral and the Bazaar.
Yeah. Guess what the cathedral is and guess what the bazaar is.
Exactly.
Open source also has the pendant in hardware. So they have bled into this world, and there's a whole organization around that, the Open Source Hardware Organization, and they have a yearly conference and all kinds of other stuff. And you will probably if you look at your Arduinos and all that, you will most likely see this symbol on there. What that basically means is that board you have in your hand, the specifications for that board is publicly available, and you can make your own copies of it. You can send this to a PCP maker, and they will make it. They won't say, hey, you don't own that design. That's for someone else's name on the design. And it allows us to share hardware designs as well as it allows us to share software designs. It's the exact same idea for hardware. It is not as I guess, significant today as open source is. But I wonder if it eventually will get to the same point where we realize collaboration around hardware is just as efficient as collaboration around software.
Absolutely.
And if you are familiar with the Arduino devices, that's really what made them succeed. They made they made two things. They made it all open source and open hardware, and they made it extremely easy to use with the IDE. If you've ever seen how you program a microcontroller before that, it was not easy. This idea that I can take my 8-year-old kid, set him in front of the IDE, and he can make his first blinking LED without me helping, would not have happened before the Arduino. But because it's open, it could grow because the Arduino company in Italy could not keep up. So much demand. So there's all these clones out, they all work because the specs are there. Now you can't just copy the PCB exactly, like that's copyright. But if you take the spec and you make your own, and you may move it around a bit, and you may optimize one of the traces and say, well, I'm going to fix this problem, or maybe I want to add this one little feature. That's what open hardware is all about.
Are there a lot of different licenses for open hardware too?
So in general, to my understanding, it follows the same type of license that we have for open source, like Commons,
Creative Commons.
Yeah, or GPL types of things, but it basically states who has the ownership and what can you do with it, right? So in some cases it may say you can use this, but you have to give it to other people. In some cases there are very restricted ones, so you can't use this commercially. You can use this privately, but we're not allowing other commercial entities access. Now, there's lots of suits all the time. People will go, you go on eBay, lots of the stuff you see on there. People will actually go online, find free to download STLs, or buy one copy of it for $10. And print hundreds or thousands of copies of that and start selling it. I mean, that's illegal. But it's a little hard suing someone living in China, right? Selling it in the US. But they do that. I mean, that does happen.
I have an unrelated question. Are they strict on enforcing the parking meters here?
It's the weekend. I'd say no.
I actually thought that they were off on weekends, but that's most places I go to.
9 to 5.
Yeah, I looked at the time, so I can speed up. I don't have that many slides left.
Okay.
I can't
I mean,
imagine.
I did have the demo though, so.
I paid with Park Mobile, but I can't imagine that they're enforced today. But so, like, I know the parking garages on the weekend don't make you pay. So it's,
I don't know. So types of software. So there's four, in my mind, there's four major types of software. And there's a little bit of overlap between some of them. But we have the firmware, which is what goes onto the Arduino or similar control board. That's what sits on the printer when you turn it on. That's what runs the control of the printer. Then we have the slicers, and they are important to make the model into something the printer understands in decode. Then we have the actual modelers that creates the model, which could come from a set of photographies, or it could be a real model like a CAD system or something else we create new stuff. And finally, you have controllers, which sort of overlaps all of this, that allows you to control multiple printers from one go, where you can basically say, I want to slice this to these 5 different printers, and they may even be different G codes, and it will send and control them all from one central point. That's great if you have many printers and you're printing, like for a company where you need to have a lot of models created a day. I've already been into some of this stuff, but I want to talk a little bit about 2 things that have been out. Well, MakerBot is not that new, but MakerBot was one of the very first successful companies for 3D printing. And the reason they were very successful was they were working around the Marlin project, which is the firmware. And they were one of the bigger contributors in making sure that they actually made it into something useful, and there was a huge set of contributors around Marlin that kept adding features. And when MegaLab would distribute a new printer and there was a problem, they just basically was relying on the community to help them fix the firmware issues that may be around to go forward. So they were pretty successful. They sold a lot of printers and they wanted to grow. And everyone knows in order to earn more money, you have to first spend more money to invest. So they got all these investors in and they started looking around and said, what the heck is this stuff? You're not selling this software, right? And they go and try to explain to them what open source is all for free and all that, and go, no, you can't do that. You have to get money, you have to sell the software too. So you have to close source it. So they did that and lost out. Not only did they lose, obviously not only credibility and all that stuff, there was a huge outroar in the community. And now they had a small company that could not keep up with the issues with the firmware because they no longer had a huge community around them being able to contribute. So ever since they did that, I checked the numbers. The last 4 years has been flatline, if not decline, going down. Basically, most makers don't consider them around anymore. They changed their focus not on the maker community because they don't think, or the investors didn't think that's where the money was. They're now selling it to commercial companies with higher-end printers. But the quality of their printers are so much lower now than they used to be with the open source. Creality is another one which is very recent with the 10CR printer. This is a Chinese company. There's a lot of these printers that are made in China by little China shops. And they are using straight up Marlin going through. And they made some modifications to it. And the last printer, the 10CR, which is one of the very popular printers because it's fairly big and can do big volume prints. And it's still very inexpensive, less than $500. But they did not publish the software at all, in the firmware for it. And when approached, they said, no, we're not doing that anymore. which meant they were now violating the GPL of the firmware they were using. So Software Freedom Foundation and a few others started taking action against them, and they realized that they may end up as Megabot. And a couple of weeks ago, I think, maybe a little more than that, they all of a sudden changed the tune and said, "Oh, here's the source code in here," and trying to deal with that. But it's interesting reading the communities around 3D printing about how they see this, and a lot of them look at it as free as in beer. And they don't understand what the debacle is about. And this is where I see some of the warning signs out there. But it's interesting to see that once these guys start cutting out the community, they get in trouble. No one has the resources the community has put together. That's just a fact of life. Which is why you see companies now being part of the community. So you may have multiple companies that compete against each other, and they're all using the same projects behind the scenes. One of the projects that I work a lot with over here is called Kubernetes, and pretty much every big software company out there, including Microsoft, is contributing to the project. And we are all using Kubernetes, competing against each other. But we could not create Kubernetes without all of us working together with Google, with Red Hat, Microsoft, IBM, everyone else around this stuff.
And if you look at that code base, it's like hundreds of man years.
Yeah, it was the top GitHub a couple of months ago. I mean, all of GitHub.
And the Linux kernel itself is a wonderful example.
Thousands of man
yeah.
years.
Yeah. I would say the kernel, I think, to me, is a little bit in a different ballgame. But yes, absolutely right. So how do we print? Well, the easy way to get started, and I must admit that's the most stuff I do, is I find someone else's design, may do a very few modifications, if any, and print it. Pretty much all you see here is stuff that I found online. So this one was one of my test print on my new printer. Is a measuring cup someone did. This is for holding a headset that I use for work. This holds a Raspberry Pi. This is a plastic bag holder, so it doesn't, get in your hand when you hold them up. This is a pegboard screwdriver holder. Just a little basket. Oh, and little Benji. Once you start 3D printing, if you don't print him, you're not a 3D printer. Benji is the test print that tells you how precise if you have any problems. It actually has a lot of different features in it that allows you to test pretty much every feature that you need to be able to print in order to have a successful print in this little print. So you will find Benji's all over, and I forgot I have a much bigger version of him at home. But Benji's all over the place. You can even print these things, which is a heart, and this is printed in one go. I did not assemble this afterwards with moving parts inside of it. By our printer. It's been a while since I moved it around, but it can move. Yep, there we go. So these are all the signs that I found online. Either through communities saying, posting somewhere, and they see, look at my design, and I put it there, and you go download it. Or I use some of the sites that you're going to see later to go find them. You can also find something that may not be free and buy it and use someone else's design. You can even go out and find a real designer and say, hey, I need this gadget made. Or it could be, I want this figurine or whatever, and they will design it for you and buy them for them. And then finally, which is what I want to really get much better at than I am, is make my own models. So why do I want other people maybe to make my stuff for me? Sometimes I can actually I can pay another 3D printer to make my stuff for me. If I need something on a very specific material that may require high-end hardware, that may be a lot faster if I just need the model, and all I need is that one model. Another thing is creating the slicing parameters is really not a science, it's an art. I have seen so many discussions, everyone arguing over what parameters is best to print with, and everyone thinks everyone else is wrong about some minute differences. It's, I guess, a little bit up to the temperament of the printer, or maybe even the temperament of the person in front of the printer that decides that. And the last one, trial and error, I'm still doing that. Printing, going, realizing I did it wrong, going and adjust the parameters, printing again, so on, so on, so on. By the way, being able to read a failed print and realize what you've done wrong takes a long time to learn. That may be the science of it, and there are some good guides. I'll have links for those in here too. So the STL, the stereolithography, whatever, is the choice of model, but it's not the only model that we can use to slice, but it is by far the most commonly used model. And again, it's a pretty old standard from back mid-80s or something like that. Again, it was meant initially for for CNC types of models, but it's a set of polygons set up inside of it. To create them, so we work with those, we create the actual objects, and in our open source we have OpenSCAD, we have Blender, or you can have LibreCAD for DXF, or even OpenCAD is also around. But there's a lot of different ways of creating actual objects that all have a export to STL option in there. And of course we have the G code that we already talked about. So here's some of the software that I either have used or I'm still using. And I must admit that the list of software in here is so long that I guess my focus was on what I'm using and instead of what's possible, because that will take too long. So Slicer with the 3, and I'm not sure why that 3 is in there. Everyone complains about it, but I don't think they could call it Slicer because I think the name might have been taken in the past. It is by far my favorite program. It is also the hardest one to use because it is the one that allows me to set the most parameters of anything out there. That is, and it's still approachable. There is a command line version that is harder than that has even more parameters, but I don't touch that if I can avoid it. The slices, what you see here, it gives me a 3D engine generate. Oh, that's something I forgot to mention. I had to put the software in this laptop. This is my work laptop because that's what I traveled with. I use a high-end disk workstation, again running Fedora with 3D acceleration, graphics cards, and so on when I do this stuff at home. And so I realized a lot of my models was on that box. I had to move them more. Make sure. I'm hoping it works when we get to that. But Slicer is by far the one that allows me to really control. I can start splitting up the models in pieces and give it different parameters. So I can say use more filament on the top and then the bottom, change color, all kinds of other stuff. Cure is where I started, and without that I probably would not have gone any further. It is extremely user-friendly. It is powerful, but because it is user-friendly, it's because it hides a lot of the options there. It doesn't make you have to make all these complex decisions about how to do it. And one cool thing about Cure is it can talk directly to the printer, so you don't even have to write it to a file and take it to the printer. You can basically, once the printer is connected, there's a connect button up here, and you hit print, and you're done. All right, well, I have to wait for it to print, but it will print directly from in here. The modeling software that I'm using is, well, there's a few more than those actually, but Blender is the one I started thinking that was the one to use. I must admit, I am very fascinated by Blender ordinarily. I have studied enough to actually not only learn how to use it for animation, but be able to do some of that stuff myself. And looking at what they need to go through has made me rewatch all these old Disney movies and go, wow. So every time there's a new cartoon out, I gotta see it because I look at how they rendered the stuff. And I remember the first time I saw Shrek, and I realized they were working on forest, and no longer to see that as an animation. They had rendered all the leaves that well, and the whole path and all the lightning was there. Knowing how that goes through this stuff makes you really appreciate what these guys are going through. But as I want to go into modeling, Blender is not meant to do CAD level. Right? So Blender doesn't really care about how big something is, how far point X is in relation to point Y. When you move the pointer, that's where it puts it. When I want to design something and put, let's say, screw holes in it, like this, I want to make sure they line up with my PCB. So I'm within millimeters, and using Blender to do that, it can be done, but it is very, very hard. So this is where LibreCAD and OpenCAD comes in, because what we can do there is to basically say that my universe, there has to be a constraint between this hole and that hole of, let's say, 40 millimeters total. And regardless of whatever that model does, if there's no 40 millimeter, it will error out and say there's no room for it, because that constraint can't be fulfilled. So it makes modeling with this stuff much easier, but it's a completely different way of modeling than Blender, so I have to really relearn a lot of stuff. OpenSCAD, which is what you see here, is designing objects for programmers. There's no drawing anywhere. You write code, and it converts that into a model. So you have to think abstractly to get a model out. You can see it immediately what you're doing, but it's abstract. You're not drawing with your mouse, you know what else you do. Printer phase is probably my favorite one for direct control and debugging and figuring out what the printer is doing. So what I've used printer phase to do is when I have the printer directly connected to a laptop, I will use this to connect up. I load in the model, and I can actually follow on the model exactly as it prints, where it is, what commands it's following. And there's a little window down there where I can fire off G-codes directly into the printer manually to diagnose stuff, figure out what the settings are, change the settings, or just manually move it around if I want to. Or I can use these buttons up here to move it around too, to control things. And so this is the way you would use it for if you do manual calibration. If you want to make sure your stable sets are set up so it actually moves 5 millimeters when you go 5 millimeters, then you will set it up to move 5 millimeters, and then you will measure on the printer how far did it actually move, and you will calculate the difference and adjust the steps, try again, until those two match. And now you have your settings. Oh, sorry, Cure, I think I mentioned already. No, I think we're down the first one. Yes, I did. Cure can actually do this too, to a certain degree. So that's another thing. And Octoprint is the one used by most people to control multiple printers at once. And finally, the hardware that I sent around earlier. By far, the Arduino Mega is what I see mostly used as the controller. What it seems to be happening, instead of having a add-on board like what you see there, this is the sort of cheap method, they're now coming all on single board like INC, where it all is on one PCB, so it takes up less space. And there's also less chance of you burning things out because it's literally meant for 3D printing out of the box. So there can't be a MOSFET that is set wrong or anything else. It's harder to short them out and stuff like that. The firmware, by far, RepRap and Marlin is the most popular open source projects. Repetier I have seen a bit used by some commercial companies. It is open source, but it seems to be just contributed by some few companies out there, particularly a company called Repetier. I think the list is about 25, 30 that comes up when you just do a Wikipedia search on them. And not all of them are as active, exactly what Rich was talking about earlier.
Most software you should demonstrate only work with the extrusion method, or they do other methods?
We do other methods too. We use it with CNC machines too. So I have not used any of the commercial software. I know they're out there. I see people talking about them. What I seem to find is you like what you grew up with. If I know Fusion, and I've used it maybe professionally, or if I know Photoshop, whatever, that's what I compare everything to. Like, because I'm not learning something new. It's doing it differently. It's doing it wrong. Right? And that's what seems to be up against when I look at these guys, and they talk about why they don't want to open source. It basically boils down to it doesn't do it the same way that I'm used to. And it's hard to learn. It doesn't mean they're better. There are absolutely things these guys could do better than the open source solutions can, and vice versa. So a little bit about, to me, it's about where you start. The only thing I will say this really makes it worth is they have training, support, and everything else around it that may make it easier to get started. At least you can call someone else's out and make it their problem. Before I do demos, here are some of the sites that I would recommend going to. STL Finder is a great, like a generic Google site for models that will go out to a lot of different websites to figure out what models are out there. And you will find both ones that are free, and then not like what Rich was saying, you can go in and set the settings of what it needs to return and what type of models do you want. Thingiverse used to be a lot more popular. It has really gone downhill. Again, company got kind of too much proprietary and wanted to start controlling certain things. So a lot of the contributors, the free contributors, left Thingiverse and went to other sites instead. So the models they find on there are usually quite old. That doesn't mean they're not good. A lot of stuff you're seeing here comes from Thingiverse. some of the different printer companies out there, like the Simplify 3D, they have great online free materials to learn about 3D printing. So if you have never 3D printed before, I think if PDF wore out as much as you read them, this would have probably worn out a long time ago. It will go through all the basic errors you can get when you print and tell you what to look for and what to adjust. And the Pruser, again, they to me win on their manuals. They have a complete guide for newbies on how to 3D print. It goes through all the basics, how the printer works, everything. All I have left is the demos, so I'll wait for that, and you saw all the stuff that I had there, and I have questions. So when I see editor in play, I notice the time, so I notice we're at the 12 o'clock thing.
No, we don't. There's nobody. It's not like being at the library.
No, but I don't want these guys to use their car.
I mean, he can go do his car. He can go do his parking meter and come back.
Yeah, I just asked for like 30 minutes more on my parking meter.
Okay.
So, go ahead, Luke. We'll wait for you.
You don't need to wait.
Okay.
So I sent you the link to that really interesting video.
Cool.
On Meetup.
So you running door 28 now? What do you?
Not yet. I have not had time. This has been a bad week for me.
So is this 27 or?
This is still 27.
28's nice. I just downloaded 28.
I'm gonna upgrade this one when we're done.
Wrong mouse. So when I do drawings, I cannot do my touchpad. I've got to have a mouse, or else I wouldn't try it.